Hello everyone. So today's topic is Boolean algebra. Let's first go through the fundamentals of Boolean algebra. Boolean algebra differs from both the ordinary algebra and the binary number system. In Boolean algebra, if we add a plus a, it will give us a. And if we multiply a and a, that means a dot a, it will give us a. Because the variable a has only a logical value. It doesn't have any numerical significance. Whereas in ordinary algebra, a plus a, we know it is 2a, and a dot a, it is a square. Because the variable a has a numerical value here. And in Boolean algebra, 1 plus 1, if you add 1 and 1, it will give you 1. Whereas in binary system, if you add 1 plus 1, it will give you 10. Whereas in ordinary algebra, we know 1 plus 1 is 2. So there is nothing like subtraction or division in Boolean algebra. Also, there are no negative or fractional numbers in Boolean algebra. In Boolean algebra, the multiplication and addition of the variables and functions are also only logical. So there are some laws of Boolean algebra. First one is commutative law. Commutative laws, it allow change in position of and or variables. There are two commutative laws. First law is a plus b equals to b plus a. These a and b are variables. Second law is a dot b equals to b dot a. We can write it. This will help us in simplifying the Boolean expressions. Second one is associative laws. The associative laws, it allow grouping of variables. There are two associative laws. First law is a plus b plus c. We can write it as a plus b plus c. Second law, a dot b into c, we can also write it as a into b dot c. Third one is distributive laws. The distributive laws allow factoring or multiplying out of expressions. So there are two types of distributive laws. First law is a into b plus c. We can write it ab plus ac, and a plus bc, this is very important. We can write it as a plus b into a plus c. Next one is idempotence law. First law we can write as per idempotence law, a dot a equals to a, and second law, a plus a equals to a. Absorption laws. First law we can write it as a plus a dot b equals to a, because if you take a common, then 1 plus b. 1 plus b equals to 1, so remaining is a. Second law, a into a plus b equals to a. Okay. Now, this law is very much important. De Morgan's theorem. De Morgan's theorem, it represents two of the most powerful laws in Boolean algebra. First law is a plus b whole bar equals to a bar dot b bar, and second law is ab whole bar equals to a bar plus b bar. Now, if we see one example, suppose this is my Boolean expression. We have to simplify this expression. F equals to a into b plus c bar into ab plus ac bar whole bar. So if you apply the De Morgan's theorem here, what we have seen here, De Morgan's theorem, a plus b whole bar equals to a bar dot b bar. So this whole bar we can write ab whole bar dot ac bar whole bar, right? Then same as here also we can write the De Morgan's theorem. What is a bar? ab whole bar equals to a bar plus b bar, right? So ab whole bar we can write a bar plus b bar, and AC bar whole bar we can write A bar plus C. This is simply De Morgan's theorem. Now you do the simple multiplication with C bar. Okay. Now, so A bar dot A bar, we know it is A bar. So C bar into A bar. Now this is the simple multiplication, C bar into A bar into C plus C bar into B bar into A bar plus C bar into B bar into C. Now C into C bar will be 0. That is why this term gives us 0. Also C into C bar gives us 0. So this term gives us 0. So these are my remaining terms. A dot A bar is again 0. A dot A bar is again 0. So these two terms are 0. So simplifying expression is AB. Okay. Now let's see another example. F equals to B plus BC into B plus B bar C into B plus D. Okay. So B plus BC into B plus B bar C into B plus D. Okay. So first you do the simple multiplication. B into B dot B plus B bar C, simple multiplication we have done. Now B dot B is B, B dot B is again B, so B into C, this is B into B bar, that means 0, this is B into B bar, again 0, into B plus D. Okay, so B plus BC, if we take B common, we'll have 1 plus C into B plus D. So 1 plus C means 1. So B into B plus D. So B into B plus BD. B into B means, if you take B common, 1 plus D. So 1 plus D means 1. So the answer is B. Right? Now we will see the Boolean functions and their representations. There are two different types of representations which is very important. One is called sum of products or SOP form. This form is also called the disjunctive normal form or DNF. For example, let's say f is a 3-variable function ABC which is expressed as A bar B plus B bar C. Okay. Now we will understand this truth table later. Let's move on to the next slide. Okay. So what is this sum of product form? So this can be derived from the truth table by finding the sum of all the terms that corresponds to those combinations or rows for which f assumes the value 1. It also can be obtained from the sum of products from algebraically as shown below. So which was our original expression? A bar B plus B bar C. You just write it. So in the first term, which variable, because it is a 3-variable function, right, ABC. So in the first term, which variable is missing? C. So multiply the first term with C plus C bar. C plus C bar means ultimately it is 1. You are multiplying this first term ultimately with 1, right? And in the second term, which variable is missing? A plus A bar. So multiply this second term with A plus A bar. Now you multiply all. So it is A bar B bar C plus A bar B C bar plus A bar B C plus A B bar C. Now you come to the truth table. A bar B bar C means it is 0, 0, 1, right? So that is why in the place of 0, 0, 1, we have written 1. Then A bar B C bar means 0, 1, 0. That is why in the place of 0, 1, 0, we have written 1. Now A bar B C means 0, 1, 1. That means in the place of 0, 1, 1, we have written 1. Next, A B bar C means 1, 0, 1. So, in the place of 1, 0, 1 also we have written 1. Okay. So, product term which contains all the variables of the function either in complemented or uncomplemented form is called a mean term. So each of these term is called a mean term because it contains all the variables of the function either in complemented or uncomplemented form. A mean term assumes the value 1 only for one combination of the variables. Okay, so I have just shown you for these combinations of the variables only we have put 1 in the truth table. An n variable function can have in all 2 to the power n minterms. It is a 3 variable function, right? So we have 8 minterms, 2 cube. That is why in the truth table we have written 0 to 7. The sum of the minterms whose value is equal to 1 is the standard sum of products form of the function. The minterms are often denoted as small m0, m1, m2, where the suffixes are the decimal codes of the combinations. For the 3 variable function, see m0. m0, how can we write? It will be a bar, b bar, c bar, all are 0, right? Then m1. m1 means 0, 0, 1. So a bar 0, b bar, this is 0, 0, 0, 1. m2. m2 means 0, 1, 0. A bar, B, C bar. M3 means 0, 1, 1. A bar, B, C. Okay. M4 means 1, 0, 0. A, B bar, C bar. M5 means 1, 0, 1. A, B bar, C. M6 means 1, 1, 0. A, B, C bar. And M7 means A, B, C all are 1. Another way of representing the function in canonical SOP form or sum of products form is by showing the sum of minterms for which the function equals 1. Okay. So if f is a 3 variable function ABC, how can we write? We can write m1 plus m2 plus m3 plus m5. So yet another way of expressing the function in TCF is by listing the decimal codes of the minterms for which f equals to 1. So these you can write as summation of m 1, 2, 3, 5. Okay. How we are writing m1 plus m2 plus m3 plus m5? We are writing from here. This is 0, 0, 1. So m1. This is 0, 1, 0, that is 2, so m2. This is 0, 1, 1, which is 3, that is m3. This is 1, 0, 1, which is 5, that is why m5. Okay. Now, product of sums form, POS. This form is also called the conjunctive normal form or CNF. So if f is a 3 variable function, suppose in the product of sum form, we are defining the function in this order. A bar plus B bar into B plus C. So this is derived by considering the combination for which f equals to 0. In the truth table, each term is a sum of all the variables. A variable appears in uncomplemented form if it has a value of 0 in the combination and appears in complemented form if it has a value of 1 in the combination. For example, the sum corresponding to row 4 in the truth table is A bar plus B plus C. Okay, this means that wherever A bar is 0, B is 0 and C is 0, this term becomes 0, and being a term in a product, the function assumes the value 0. Thus, the function f of ABC equals to A bar plus B bar into A plus B is given by the product of sums. Okay, A bar plus B plus C. So if when we had the canonical sum of product form or mean terms, we have seen we are telling it as 0, 1, 1. right? But here A bar we will consider it as 1, B 0, C 0, 1 0 0. Okay. So how we will simplify this expression? In the first term, which variable is missing? C, right? Because it is a 3 variable function. That is why we are multiplying we are adding this C dot C bar. C dot C bar means it is 0. We are just adding a 0 with the first term, right? And in the second term, this is A bar plus B bar plus C bar, right? And then how we will simplify this term? How we will simplify this term? A bar plus B bar plus C bar, okay, into A plus B plus C dot C bar. Okay, so if you simplify this form, you will get the result. Only in the first term, which variable is missing? C. So we will add C plus C bar here. In the second term, which variable is missing? A. So we will add B plus C plus A dot A bar, and we have to simplify the expression. The sum term which contains each of the n variables in either complemented or uncomplemented form is called the max term. Okay, the max term assumes the value 0 only for one combination of the variables. For all other combinations, it will be 1. They are just completely opposite to your min term or sum of product form. There will be at most 2 to the power n max terms. The product of max terms corresponding to the rows for which f equals to 0 is the standard or canonical product of sums or form of the function. So max terms are often presented as capital M0, M1, M2, where the suffixes denote their decimal code. So if your max term is M0 dot M4 dot M6 dot M7, we can write it as summation of M0467. Now we will consider one example. So we have to expand this expression to min terms and max term. So as we can see, this is a 4 variable function. And in the first term, the variables B, C, D are missing. In the second term, so what we have to do if we want to expand in sum of product form or min term form, so what we have to do? We have to multiply B plus B bar into C plus C bar into D plus D bar, right? With the first term. In the second term is B, C bar. So the variables A and D are missing. So we have to multiply this second term with A plus A bar into D plus D bar. In the third term, which variable is missing? C is missing. So we have to multiply with C plus C bar. In the fourth term, all the variables are present. So we will leave it. So if you multiply it for the first one, just multiply it. So we will get it, this function. For the second one, BC bar, we have to multiply with A plus A bar into D plus D bar. Just see after multiplication, ABD bar, we have to multiply it with C plus C bar. Then you just add all these. So what is ABCD? That means 1 1 1 1. That means 15, right? 1 1 1 0, 14. Likewise, then 1 1 0 1, 13. Likewise, we have to write all these min terms with suffix as the decimal digit. And this we can we already know that we can finally express it as summation of M 4, 5, all the suffix we can write here. So this we have expanded this expression to min terms. Now we will see how to expand it in terms of max terms. So you can see these are my min term form. Okay, these are my min term form. Now, or sum of product form. So, in the sum of product forms, we have to identify which min terms are missing. which minterms are missing starting from 0 to 15. So these are the minterms that are missing 0, 1, 2, 3, 6 and 7. So in the product of sum forms, these will be the max terms. Okay. The missing terms in the minterms will be the max terms in the product of sum forms, and these terms, they have to be present. So the product of sum form will be sum of capital M 0, 1, 2, 3, 6 and 7. Okay. Now, what is my expression? A plus BC bar plus ABD bar plus ABCD, right? In the A, so it is a 4 variable function, right? It is a 4 variable function. This we already got the product of sum form or the max term form. Okay. Now, another way of solving it to find the minterms is A. It is a 4 variable function, right? Because this function is a 4 variable function. So first, the least significant bit, the most significant bit is A. Okay, ABCD, it is a 4 variable function. D is the least significant bit and A is the most significant bit, right? So we will write most significant bit A as it is, and here we will put XXX because we don't know what is that, right? Now we will put A as 1, and starting your first digit is 1, and we have to find out what kind of combinations, 4 variable combinations are possible with the first digit 1. Okay, because A is the first variable. So what kind of combinations are possible from 0 to 15 with the first digit as 1? 1000. Make sure all these combinations are possible from 0 to 15 with the 4 variable function, provided the first digit should be 1. So we can, 1000 is M8, 1001 is M9, 1010 is M10. We can represent it in terms of the minterms. Then BC bar. BC bar means the ABCD is my 4 variable function, right? So A we don't know, we will put it as cross, and BC bar 1 and 0, we can put 1 and 0 because C bar is complemented. C is complemented, right? And X is also, we will put it as D also we don't know, so we will put it as 0. Now we will write the 4 variable function starting from 0 to 15 with the mid digit 10. So these 4 combinations are possible. With these B and C should be 1 and 0. So it is, after simplifying in the form of minterm, it will be M4 plus M5 plus M12 plus M13. So the third term is ABD bar. Only C is missing, so we will put cross in the place of C. So this X can be either 1 or 0. Okay, so AB is 1 and D is 0. So 1, 1, X, 0, we have to identify how many combinations are possible starting from 0 to 15 with this 1, 1, X, 0. And X can be 0 and 1. So these 2 combinations are only possible. This 1, 1, 0, 0 is 12 and 1, 1, 1, 0 is 14. So now if you add, and ABCD, all the variables are present, we don't need to do anything. Now if you add all these minterms, you will get this, and this is nothing but we have started this formula, right? So this expression, this expansion, you can also do it in this way. This is just another way of solving of these expansion that we have expanded to minterms.